Okay, we're going to get started. This is the CDSS SNODAS tools training. The presentation is being recorded. We're going to try to put this on YouTube. The training overview will give a brief introduction about the organizations that have been involved in this project and provide some background for the need for SNODAS, the background on SNODAS itself, as well as the tools, and then we will move to a demonstration. The resources that are on the last slide of this presentation were also emailed in the attachment that you received for this webinar, and the link at the bottom of the screen was also in that email. And if you want to follow along by using the online application during this presentation, feel free to do so. In particular, if you have multiple screens, it may be handy for you to watch the presentation on one screen and try the application on the other screen. Because of the number of participants that we have, we are going to have everybody on mute during the call except for myself. As we get to the end, there will be a time for questions, but if you do have questions during the presentation, please type them into the chat window and we will try to catch those as we go, or we will talk about them at the end. The funding for the project came from the Water Conservation Board from a severance tax grant. The CWCB has many programs related to water, and I'm sure that most of you are familiar with that. You can go to their website to learn more. Related to this project and snow data, the CWCB has responsibilities including drought planning and water supply planning. They also have weather modification, including cloud seeding programs to try to increase the snowpack. The CWCB also co-chairs the Water Availability Task Force, which has duties related to informing people about water supply and drought conditions. And there's a Water Forecasting Partnerships Program, which seeks to provide additional information to give organizations lead time to help them with forecasting their water. The Open Water Foundation is a nonprofit that focuses on developing open source software and open data tools to make better decisions about water resources. We are located in Fort Collins, Colorado, and we've worked on many projects for the state over the years, including the decision support systems and currently the Swazi Update project. The presenters today, my name is Steve Mahlers. I'm the founder and Chief Technology Officer of the Open Water Foundation, and Emma Giles is the GIS developer who did much of the technical work on the tools that you'll be seeing. We had other people contribute as well within Open Water, and the state helped to ultimately get the product installed on the website. The need for SNODAS tools is to provide an additional data for water supply planning. And it is not meant to replace other programs and tools, but it is another resource that can help provide useful information. Many organizations depend on the SNOTEL stations. However, some basins do not have SNOTEL monitoring stations. And existing monitoring stations are not representative of snow conditions across the entire watershed. Water managers also lack late season information because the snow has melted out at observing stations, and we need watershed specific snow water equivalent products for water supply forecasting. Just to give a brief overview on SNOTEL, so this is an NRCS website. The link is at the bottom and is also in the resources. So most of the SNOTEL stations are at high elevations at the divides between basins, and so this is limiting because there are many parts of basins that do not have those point measurements. A typical product from SNOTEL is the graph that you see here. Sometimes there will be multiple years or other statistics on the graph. This is a basic product. The current year snow water equivalent shown in inches is the blue line, and the red line is the median over a normal period. In this case, it's 1981 through 2010. The gray and the black lines show the water year precipitation accumulation. The black line is the current year, and the gray line is the average precipitation for that normal period. So this data product shows a daily condition data of snow water equivalent, as well as the cumulative seasonal values.
SNODAS stands for Snow Data Assimilation System. It is a modeled and gridded data set representing snowpack measurements across the contiguous U.S. It is created by the National Operational Hydrologic Remote Sensing Center, known as NORISC, and is hosted by the National Snow and Ice Data Center via their FTP site. The SNODAS grids are created daily and include snowpack measurements of snow water equivalents, snow depth, snow melt, sublimation, precipitation, and snowpack temperatures. The archive of daily data reaches back to October of 2003. The SNODAS grids are approximately 1 kilometer in resolution. This slide is showing a daily SNODAS grid overlaying the Joe Wright Reservoir area for May 4, 2018. In the middle of the map, you can see the point snowtail station for the reservoir, JWRC2, also known as snowtail station 551. The point data measures one specific measurement of snowpack statistics, while the SNODAS data supplies an understanding of the snowpack at a landscape scale. The SNODAS tools aggregate the gridded snow water equivalent statistics on a basin scale to understand the overall conditions of the snowpack for each basin. Here we have a graphical representation of the previous slide. As you can see, the May 4 snow water equivalent measurement for the Joe Wright Snowtail Station is approximately 23 inches. On the second graph, we have the basin-wide average, calculated with the SNODAS tools. You can see that the basin average for May 4th is approximately 8.5 inches. The values vary given the different approaches. The SNODAS tools calculate snowpack statistics on a basin-wide scale. The choropleth map on the main window of the SNODAS tool site displays the average snow water equivalents for each basin given a specific date. To create these averages, Open Water has developed software that runs on a daily schedule. It runs 2 times per day, once at 8 a.m. and again at 6 p.m. Mountain Time. The second run only processes SNODAS data if the first run of the day fails for some reason. The software takes about 30 minutes to run, so the SNODAS Tools application should be updated and available for view to users around 8:30 in the morning. The process first downloads the daily national SNODAS grid. It then clips the grid to the Colorado watershed basins. Zonal statistics are calculated for each of the basins, in particular the average snow water equivalents and the percent snow cover measurements. These statistics are then output into 3 formats: comma-separated values, GeoJSON, and shapefile. The CSV files are processed into time series graph products, and then all output products are published to the web. The watershed basin boundaries used to process the SNODAS tool statistics are provided by the National Weather Service River Forecast Centers. There are also a few elevation-specific basin boundaries that were provided by Northern Colorado Water Conservancy District, and those are located in the northern central area of Colorado. I'll now pass this over to Steve, where he'll give you a demonstration of the product.
Okay, so again, if you would like to follow along and look at your own basin's data, feel free to do so. This application is designed as a single web page application, so most of the information is within the width of the screen. It is not designed for mobile devices at the moment, so it's better viewed on a desktop computer with a large monitor. The About section on the left of the application provides basic information, provides a link to the NORISC site if you would like to go look at the national gridded products, and there are contact information at the bottom of the section. The data section provides links to all of the data that's used in this application. I'll start at the bottom. There are some static information, including the map layer for the basins, as well as an Excel spreadsheet that lists all of the basins and provides connectivity from upstream to downstream, which is used to compute the totals above a point. In the upper part of the data section, there are links to the data files, and there are two primary products that are produced. One are files called State Statistics by Basin, and this is a historical representation from the start of SNODAS data to the current day, and the files are named with a identifier according to the basin. And if you mouse over a basin in the application, you will see the local basin ID. That is what's used in the file name. And there are some examples of file name patterns that you can follow to match a download file. That was statistics by basin. The other product is statistics by date. That is a file that is named for each day, and it includes the statistics for every basin on that day. This product is more suitable if you just want to see what the current conditions are at a point in time rather than downloading the entire historical data set. Most entities will want to look at the historical data for their specific basins, but they don't need to download the data set for the entire state. The files are distributed in comma-separated value to simplify processing by other applications, and the spatial files are available in GeoJSON and shapefiles, as Emma indicated. We also have included documentation on the website, and this was an experiment using a new documentation tool. This is an open source project, so we have all the software and the documentation on the web, and we hope that this will be improved over time. But if you're interested in learning more about how the processing was put together, you can go to the documentation links, and it shows, for example, how to go from the national grid, intersect with Colorado's basin boundaries for the extent of Colorado, as well as then clipping the national grid and processing that data. Going back to the web application, there's a few basic things you need to know, but we designed it to be fairly simple to use. The entire map can be moved by holding down your mouse and just shifting the entire map. You may need to do that if you're in the southern part of the state and the pop-ups are obscuring what you would like to see. When you first load the application, it will show the current day's data, which is in the date being listed in the upper right. If for some reason you've left this running on your computer for several days, you may need to refresh that page in order to bring up the most current data. You can mouse over any basin to see basic information for the current day, and that's shown in the pop-up that you see in the lower left. This includes the basin identifier and name, as well as some of the statistics. Again, the basins were taken from the National Weather Service River Forecast Center, which is where those IDs come from, and your basins may have slightly different configurations, but hopefully the information is still useful to you. If you click on a basin, the outline of that basin will be frozen so that you know that that's what you clicked on, and then there are buttons on the lower right which provide graphical data products, which we will go through. You can also animate the map, and we'll go through an example of that as well. So I clicked on the Caneos, which when we did our demonstration last week still had some snow, but according to what we're seeing now, it has melted out. So if we look at the snow cover graph, this shows from 0 to 100% what is the area of the basin that's covered by snow. And you can see that we've, I guess there's a small amount there, but for the most part it is melted out. And you can also see the impacts of when storms come in, especially in the early season and the late season. It's quite dramatic in terms of the ups and downs due to the temperatures. So this product is useful for the late season when you're interested in knowing, is there any snow in the basin that may not be indicated at the SNOTEL station. The snow water equivalent graph is similar to what the NRCS puts out for SNOTEL. The difference being that this is an average product over the basin rather than just at a point as SNOTEL is. So in this case, the water year 2018 is highlighted in blue, and as you can see, it's a a low water year compared to the other years. SNODAS has been available since water year 2004. Because it is a simulated result, the algorithm has actually been changed over time as they've tried to improve it. So comparing one year to another is not exactly comparing apples to apples. However, if you can live with that caveat, you can get some useful information. Clearly, things like maximum and minimum and relative position are helpful, but if you compute means and medians, the numbers have changed over time. The snow water equivalent volume graph is similar, except what we have done is taken the average depth of snow water equivalent and multiplied that by the effective area of the basin to give an acre-feet estimate of snow water equivalent within that basin. The computation takes into account some factors such as missing data and large water bodies. Large water bodies are treated as differently than land area in terms of showing snow water equivalent that's available. There's also a line on the graph which shows the 25% melt out line. We take the maximum number in the year and take 25% of that, put that as a line. That is an indicator that you have perhaps 2 or 3 weeks left before the snow melts out, and you may need to be making some operational decisions based on that. Similarly, there's an upstream total graph which takes the total snow water equivalent volume of the current basin as well as the upstream basins. And that's where that Excel spreadsheet with the basin connectivity is used. In this case, there's not a lot of additional incremental area for this basin, but you can look, for example, at a state line basin and see the entire contributing area. The 1 week change product is useful to show when you're in a time of accumulation compared to melt out. And in this basin, there is an inflection point roughly at the start of April when we change from accumulating snow to melting that snow off. It's a bit noisy, but it is useful to show where things are in the historical perspective. There's also a cumulative snow water equivalent product. This is similar to the SNOTEL Cumulative Precipitation. In this case, what we've done is taken all of the positive increments of snow water equivalent that occur daily. So as a storm comes in, there will be a jump, and we've added these up for the water year. And it's an indicator of the total amount of water that's been put on the basin. So the instantaneous condition or the daily condition may indicate one situation, but the amount of water on the basin may vary slightly from that. So in this case, even though the daily graph showed that this year was pretty much the lowest of any year, from an accumulation standpoint, it was the third lowest according to this data set. And then similarly, you can do the same thing for the total upstream. So if you have a water collection system, you can find a basin at the low end of that system and try to get an understanding of how much snow is sitting above that point. The animation tool, I should say that these products are available only for the current day. We don't currently allow you to pick a point in history and look at those graphs dynamically. That may be an enhancement that is added to the system. The animation tool in the upper right is interesting, especially if you look at the entire water year. In this case, I've put in 2017 October 1st and 2018 through the current day, and I've put in an increment of 7. The default is 1, but it takes a little bit longer to run, so for the purpose of this demonstration, I'm putting in 7. And then you press submit. It will reset the map to the beginning day, and then you can run that animation. And what you'll see in the early part of the season is that snowstorms come in and then the snow melts, and it takes a while for it to start accumulating. Now we're at the end of 2017. It's also useful to get a sense of maybe there's some soil moisture impacts of these storms out on the plains. And there we've looped to the end. It stops on an even increment of 7 days from the starting point. We've also done some additional visualizations, and the idea is to use the core products, the core data that we've developed to try to look at data in different ways. One of these is called the Gapminder Visualization, and this is available on the Open Water Foundation website. If you go to viz.openwaterfoundation.org, there are a number of visualizations there. We're also trying to link these types of things into the main SNODAS tools, but there is additional data processing that has to be coordinated. I ran this a few days ago, so let me explain what we're looking at. Every one of these dots is the same corresponds to a basin on the map that you saw previously. So every time you mouse over and move around, the lower left will update its display, and you can see the local ID, which matches something that was in the original SNODAS display. The basins that are displayed here are grouped according to larger basins, which is in the upper right, and we're using the River Forecast Center groupings. So AB is Arkansas Basin, CB is Colorado Basin, MB is Missouri Basin or South Platte. NC is actually the NCWCD is the Northern Water Basins, and WGRFC is the West Gulf or Rio Grande Basins. So on the x-axis, we have the cumulative snow water equivalent through the season. Those are the graphs that I showed you at the end that are a stair step up over time. On the y-axis, we have percent of mean for the data set that we have for SNODAS. And again, we are living with the caveat that the modeling may have changed over time, so every year is not exactly consistent in the approach that was taken, but for this visualization, it's useful information. So I'm going to start the animation. I've already played it through once, but I'm going to replay it. What you will see is that this marker down at the bottom, this scroll bar will move over time, indicating what day of the year that we're on, and you will see at the beginning it's a lot of spread, but then it settles in, and then as storms come up, it will jump a little bit. So let me get that started. It may jump a little bit also because we're going through a go-to meeting. So clearly we settled in a lower pattern for some basins. What you can do with this tool is you can grab the slider here and move it to any day that you're interested in. We can also click on a basin in the upper right. When we do that, it highlights this basin, and then you can again move this through. You can rerun the animation and it will show these basins highlighted. There is a tracer feature which will follow those markers, and you can get a little bit of a sense of are things going up or down, but that's pretty busy. It's basically showing the graphs that we've seen before superimposed in this way. So if we look at the Arkansas Basin, we're at low conditions as we know, and this again is seasonal accumulation. If we look at West Gulf, which is Rio Grande, slightly better but still pretty low. Colorado Basin in the 70% of median range, and the Missouri is a bit higher, and then northern basins are better. So as you move north this year, the snow conditions get better. Another visual product is the State of Colorado's Map Viewer. This is available on the CWCB website, and there are several versions of the map viewer. This one is focusing on the snow conditions, and the state has configured this website to have other additional layers that might be of interest, but the Snowpack Assessment is the layer that we are talking about, and they have the same information that I've been talking about available through this interface. The advantage of this tool is you can combine other layers that are offered by the state, and their map is also showing the acre-feet total. This is the daily value, so that's a useful product as well if you want to use this form. So potential enhancements for this tool is to add more map layers and watershed information for context. For example, other basin boundaries or cities or transportation. There's also interest in showing SNOTEL data. This is complicated because every basin that we have for SNODAS has 0, 1, or potentially more than one SNOTEL stations, and that information needs to be cross-referenced and properly displayed. We're improving the interface based on feedback, so if you are using this tool and you have any feedback, please, you can contact myself. My email was sent to you, or Joe Busto at the State of Colorado. That information is on the web application in the About tab. There's also interest in developing some relationships between SNODAS, snow water equivalent, and streamflow forecasts, so that at a local level for a specific water supply system, you have information that can leverage the SNODAS data in addition to SNOTEL and other information that you have to give another bit of information to help you make decisions about water supply planning. We may produce some additional analysis products like the animation that I showed, and we may add additional support for mobile devices. At the moment, we do not have a project with funding to do any of these things, so we are looking for help and partnerships. The resources were again included in the attachment to the email, and this presentation will be put out as a video, so you'll be able to come back and see these resources. These are the main data visualization tools that we've shown today, and feel free to use that, and again, give us feedback on those as well, and we might be able to do a better job integrating those together.